Hi everyone. Now that we are familiar with lines in the form y equals mx plus b, today we're going to be taking a look at lines that are in standard form. So let's get started. So we've seen one way of writing a linear equation, but there's three types. So the first type, the one that we've seen, is slope-intercept form of a line. When the equation is written as y equals mx plus b, we know m represents the slope and b represents the y-intercept, and x and y represent a point on the line. There's also point slope when the equation is written as y minus y1 equals m times x minus x1. And then standard form of a line when the equation is written as ax plus by equals c. So this is the form we're going to be focusing on today, standard form. Okay, so standard form of a line. Can we graph the following equation just by looking at it in this form? So we were used to y equals mx plus b, where we can easily see the slope and the y-intercept. Now ask yourself, do we know what the slope would be here? Do we know what the y-intercept would be? So some students would say, oh yeah, 3 is the slope, but that's not the case here because y is not isolated. So we have this 4 in front of the y, so we can't say that this is the slope because y has to be by itself. So the answer to this question is no. We're not able to see the slope and the y-intercept just by looking at that equation. So what we need to focus on is writing this in slope-intercept form. Okay, so we want to put the following equation of a line into slope-intercept form, simplifying all fractions. So whenever we're doing this, the goal is to solve for y. We want to get y all by itself. We want to isolate it. Okay, so let's get started. Step 1 is we are going to add or subtract the term containing x. So we have this 3x, this 4y, and this negative 12. So we're going to move this 3x. We want to get this away from the y. If you want, you can draw your train tracks because this is very similar to using the same steps when we're solving equations. So we are going to go ahead and, because this is a positive 3x, I'm going to subtract it on both sides because the goal is to cancel it out. So that cancels out. And pay close attention to what happens here. I'm going to bring down this 4y, that positive 4y. Now, negative 12 and negative 3x are not like terms. This has an x, and this negative 12 does not have an x. So we can't subtract them. Remember, we want it to look like y equals mx plus b. So what I'm going to do is I'm going to take this minus 3x, this negative 3x, I'm going to put it right in front. I'm going to put it in front of that because I want the term with the x to go before the constant. So it's going to look like this, negative 3x, and then I'm going to just bring down that minus 12 right after it. So we can't combine them. We're going to write them next to each other, and we're going to put that term with the x in front so it's closely to this form, y equals mx plus b. Okay, so that's the first step. Second step is we're going to divide every term by the coefficient, which means the number in front of y. So here we still have y, it's not isolated. We have that 4 in front of it. So we're going to divide every single term by 4. So these 4's are going to cancel out. So we're left with y over here. Now negative 3 over 4 is a fraction that we can't simplify, so I'm going to just bring it down. If you can simplify, you definitely should. You might be able to write this as a decimal for delta math, but when you're graphing it, you want to leave it as a fraction so you can see the rise and the run and the slope. And then here we have negative 12 divided by 4. This is something that we can simplify. Negative 12 divided by 4 is a negative 3. Okay, now it is in slope-intercept form. So step number 3 was to simplify fractions if needed. But now we can see the slope. The slope is negative 3 over 4. The y-intercept is negative 3, and we can graph it just like this. Okay, let's look at another example. Okay, put the following equation of the line into slope-intercept form, simplifying all fractions. So the first step, well, I'm going to draw those train tracks. Let's stay organized here. And then the first step was to add or subtract the term with x. So here we have this negative 2y in front, minus 3x equals 18. We want to move the term with the x. So most of the time it is going to be written in front of the y value, but sometimes it won't be. We have to remember that our goal is to solve for y. We want to get y by itself, so we always have to move this x value first. So because it's a negative 3x, I'm going to add 3x on both sides. This is going to cancel out, and we're left with negative 2y over here equals, now same thing as before, these aren't like terms, so we're going to just take this and put it right in front of the 18. So we have positive 3x, so I don't really need to put the plus, but you can if you want to. And this is a positive 18, so we're going to put plus 18. So we're not combining these, I'm just taking that value and putting it right in front, because remember, we want it to look like this, y equals mx plus b, so that x term is going to go first. Now, let's divide everything by what's in front of y, which is negative 2 here. So we're dividing everything by negative 2. That cancels, and we're left with y equals, this is going to become negative 3 over 2. That's a fraction we can't simplify, so we're going to leave it alone. And a positive divided by negative is negative, so it's going to make the whole thing negative. And then we have a positive 18 divided by a negative 2. That's going to give us a negative 9. Now we can see the slope, which is negative 3 over 2, and our y-intercept is negative 9. That's exactly what we wanted. The y is isolated, it's all by itself. So that's how we translate these into slope-intercept form. So always move your x value by either adding it or subtracting it. Make sure not to combine it with the constant because they're not like terms. And then divide every term by what's in front of y. That's how you get the y by itself.